All right, let's try another example where we have to identify all the characteristics of a quadratic quadratic function. Remember that you need to start by figuring out if you have standard or vertex form. Here, I don't have any parentheses, which means standard form. So if it's standard form, I'm going to have to do a little bit more work to find my vertex, which we know is the ordered pair, HK. So when you're in standard form, remember that H is equal to negative B all over 2A. To use this, you need to make sure that your original function is in descending order, which means that you start with your highest exponent and work your way down. Here we go from x squared to x to the first to our constant term, no x's, so we're okay. We find out that A is negative 2, B is a positive 12. In case you just want to complete it, C would be negative 5. Okay? So plugging in, we're going to have the opposite of B, which is 12, all over 2 times A, which is negative 2. Negative 12 all over negative 4 gets us a positive 3. So we know the first coordinate of our vertex is going to be 3. To find the second coordinate of our vertex, the k is equal to f of negative b all over 2a. But we just found out that negative b all over 2a is 3. So we need to find f of 3. But in this case, we don't have an f function, we have a g function. It means the same thing. It's just when you have multiple kids, you don't name them all the same name. That's why we have f of x and g of x and h of x and so forth and so on. So plugging in, we're going to have g of 3 is equal to negative 2 times 3 squared instead of x squared, plus 12 times 3 minus 5. You can put this into your calculator all at once. Just make sure that you watch your parentheses. Otherwise, if you're doing it in pieces, make sure that you do not drop your signs. You should have negative 18 plus 36 minus 5, and we wind up with 13. So our ordered pair for our vertex is 3, 13. We need to figure out whether the vertex is a min or a max. So we just found that A was negative 2. Negative 2 is less than 0. You said it's negative. And if we're negative, we're unhappy, we're frowning, which means our vertex is hanging out at the top, and our vertex is a maximum. And that's all because the leading coefficient was negative. Next, we need to do the domain. Remember, domain of a quadratic, we can plug in any x value we want, which means that we are going to have negative infinity to positive infinity as our domain. I'm going to skip over range for a second. We'll cover that in just a moment. Let's pick up axis of symmetry. Remember, your axis of symmetry is in the form x equal to h, and you have to have the x equals there because it is an equation. And the h coordinate of our vertex was 3, so our axis of symmetry is 3. Let's go pick up our range and the increasing and decreasing. If you are unsure of yourself, you can use a calculator and graph this. Otherwise, let's just sketch it. We said that our graph is opening down because A is negative. We know our vertex is hanging out at the top. And we also know that our axis of symmetry is cutting through the center. This time when we're looking at the range, our graph will keep going and going and going and going and going down, 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 which means it's never going to stop going down. It's going to keep heading towards negative infinity. So when I'm looking for my range, my smallest value is going to be negative infinity. So now we need to find out the top. What is going to be the biggest y value I can be? So at the very top, we find out that our y value is 13. And since it is our range and we can actually hit 13, we're going to have a bracket. If your graph is opening down, this is the form of your range. It'll be negative infinity to the y value of your vertex or your k value. When your graph is opening up, it's your k value or the y value of your vertex on up to positive infinity. Let's tackle the intervals of increasing, decreasing. Reading from left to right, we are going up. And since we are going up, we are increasing. And we hit our vertex. It's like we're coming over the top in the roller coaster and we slide on down. And since it's going down, remember that means that we are decreasing. We've identified the areas on the graph. Now we need to put it in interval notation. Okay, I already have my axis of symmetry as the cutting point in between the two. Remember, to the left we have negative infinity. To the right we have positive infinity. And that gives us our intervals. We just said in between negative infinity to 3, we are increasing. And we have a parentheses around the 3 because we can't make up our mind at 3. We could go back or we could go forward. So no brackets, just parentheses. On the other side, in between 3 and infinity, we are going to be decreasing. And this is how you go about identifying all the different pieces for problem just given with the function.